This is from today's weekly contest. Contest 366. Start the A problem. Divisible by and non-divisible by some difference. So you are given number n and given m. You have to return the, let's call it sum 1 minus sum 2, where sum 1 is equal to the sum of integers in the range from 1 to n that are not divisible by m, and sum 2 is the sum of integers in the range 1 to m that are divisible by m. So that's a straightforward question. You go iterate over 1 to n, see whether the number is divisible or not by m. Based on that, you put it into either sum 1 or sum 2. Then at last you do return sum 1 minus sum 2. Okay, this is sum 1, this is sum 2. Sum 1, okay, S1 and S2 represent sum 1 and sum 2. Accepted, okay, let's move on. Minimum processing time. Okay, so in this you are given two arrays. One is the processor, which represents the processor time, and second is the task array, which represents the task. What you need to do is basically assign a task to a processor optimally so that the minimum time is to finish all the jobs is minimum as possible. Okay, so what happens, how the jobs happen? So each processor copies himself four times, basically has n cores, so n into four tasks need to be executed, so that only one task. So each processor can do four tasks, you can say, and the task array will always be the size of n into 4, where n is the size of processor. Okay, then yeah, basically the time at the processor available for the first time, and the integer at task represent the time that it executes. So this is the time when processor becomes available. Okay, and this is the time of the task requires to complete. So it's better to take the processor starting at 8 to do some bigger task. It's starting early, and yeah, otherwise if you take 10 to 5, like the logic is simple. The problem says that you have to take addition of the processor value at the time it starts plus the time which takes to complete. So 8 plus 8 is 16, but 10 plus 8 is 18, so it's better to give 8 to this 8 task. So I choose 4 biggest value, give them 8, and then the next 4 values give them 10. That's all. If there were 3 processors, then I would have gone that for that. So basically what I need to do, sort processor, sort task, but smallest processor should get the biggest. So the processor which is starting at the smallest time should take on the biggest task. So that's why I think I reverse sorted the task array. Okay, so that biggest tasks are first, second, and so on, and so it's decreasing. So and processor is just sorted. So first processor will take up the starting four tasks. Okay, yeah, because first processor is the smallest of them, and first four tasks is the biggest of them. How do you get it? So I divide by 4. If the number is less than 4, it will be done by the first processor. If it is between 4 to 8, it will be done by the second processor, and so on. So you just say key p of I by 4. So I sorted task, sorted reverse sorted processors. This also could be one of the approach. The smallest task is going for the processor which are starting late. Again, the logic remains same, that ti plus pi by 4. Pi by 4 इसलिए because yeah, like 4 tasks could be taken up by single processor. Let's see the fourth problem. Apply operations on array to maximize the squares. apply operations on array to maximize the sum of squares. So this is the array given to you, and you want to maximize the sum of squares. But you have to select only k elements. So basically, if you choose two elements from this 8 and 5, you will try to pick. But some operations which we can do to maximize the element itself, and then we can take the squares. So the maximum element which we can do is basically on this operation. When we pick two elements, we get the next two element as or of them and of them. So the or becomes greater than both and becomes smaller than both, and k is equal to 2. But yeah, then we try to pick the k maximum elements from that. It's good as like the observation is really straightforward that bits are shifting from one to other. Basically, this bit which was shifted in the 5 is going to 8, because 5 has 0th bit 1 and second bit 1. 8 has third bit 1. When it goes to that, then now 8 becomes something like 13, which has every bit 1 except the first bit, and 2 also goes. First bit is also 1. Now it is 15, and 15 and 6 gives you the good combination, because taking 6 into 15 again does not make any sense, because or remains 15. So how would you do that? So to observation, I would like to write on top of it. First is to make numbers as big as possible. So we don't care about like taking k numbers. That is not focus, but focus is to get the maximum number. Second, bits can shift from one number to another. So basically what we will do is nothing thought of it, and really simple. We just calculate the count of each bits. Count sort on bits, number of set bits. X shift by I. That's it. Now what you need to do, we will go for I 0 to k. We go for k numbers मेरे को बनाने हैं. Numbers मेरे पास ये choice है कि मैं खुद से बना सकता हूँ. That I from 0 to 32, like number int nz, usually 0. If c of I is something, then what I can do, ci minus minus, and nz plus equal to or equal to this, and then you basically res plus equal to nz into nz. यहाँ पे लॉन्ग res बनाना पड़ेगा. Looks good. These were the only two observations in this problem. Mod is not defined. 325. Okay. 325. Okay. I minus minus. ठीक है ऐसे सही है रन टाइम यहीं पे इशू है एग्जिट को लॉन्ग लॉन्ग बना दो ओके
अरे कुछ है तो तेरा दे दे पैस वैस सब
okay accepted so that was first three not first three first second and fourth third one we'll do soon okay bye